This is lecture 5.1, review of fractional and negative exponents. So we are on the student note packet chapter 5 now, which is the purple set of pages. I'm going to do the examples from page 2. You guys are going to include these in your homework scan, and then you guys are going to do everything on page 3 in a separate piece of paper showing all of your work. There are rules at the very top of page 3 in a box. Those are just the rules that you guys need to know dealing with fractional and negative exponents. Hopefully this is review from Algebra 2. But I will say these are tricky things, and the problems from this unit tend to be the most commonly missed problems on the final exam. So we want to make sure you guys are really good with applying the rules of exponents, and you can do it quickly. So number 1, we're going to start here. We've got 16 over 49 to the negative 3/2 power, and we want to simplify this. Now, this is something for all of the problems in this unit. I'm going to expect to see some work here. So if you're not showing any work, I'm giving you guys the answers. If I just see a piece of paper with all the answers, you're going to get 0 points for homework credit. So let's make sure you guys are showing all of the steps just like I'm about to do in this lecture. The way we're going to approach exponents is we want everything in simplified base, the smallest base possible, and then we can start manipulating the exponents. So what I mean by 16 and 49 being in their smallest base is 16 is a power of 2. 16 is 2 to the 4th, and 49 is a perfect square, it's 7 squared. So if I have 16 and 49 expresses 2 to the 4th power over 7 squared, I can then start to kind of see where this might simplify a little bit. Okay, rules of exponents say this. If I have a fraction being raised to a power, I can take that power and apply it both to the numerator and the denominator. When I have a power being raised to a power, we're just going to multiply. So this is going to become 2 to the negative 6 over 7 to the negative 3. And then we've got to deal with those negative exponents as well. Your final answers will never ever include a negative value as an exponent. So we want to make sure that we deal with that negative 6 and that negative 3. Rules of exponents tell us we just switch numerator and denominator to take a power from a negative value to a positive. So I can just swap like this. Move 2 to the negative 6 to the denominator, it becomes 2 to the positive 6. Move 7 to the negative 3rd to the numerator, and that becomes 7 to the positive 3rd. And then we're just going to simplify now. Nothing else we can do. The bases in the numerator and denominator aren't the same. So all I can do is 7 cubed, which is 343, over 2 to the power of 6, which is 64. And we leave that as a simplified fraction. That's how your answers are going to be. You're never going to give me a decimal value. We want to show all the steps there. So if you don't have all those steps, you're not going to get full credit on the homework and on the tests for this unit. All right, number 2, same thing. I'm going to take 4. I'm going to put it as 2 squared, and then I'm going to distribute that power. We get 2 to the negative 5th. Now I'm going to deal with that negative power by taking 2 to the negative 5th and putting it underneath 1. And then I can express 2 to the 5th as 1 over 32. Final answer there. Number 3, 243 over k to the 10th to the power of negative 3/5. I can do this a little bit differently than we did numbers 1 or 2, so it looks more similar to number 1. Instead of distributing the power first, what I can do is get rid of the negative exponent first, and that works as well. I can just make this k to the 10th over 243 to the power of positive 3/5. That's the same thing. So different steps you can do in different orders with exponents. And then I'm going to distribute that 3/5 to the numerator and the denominator. I am going to change 243 first, though, to 3 to the power of 5. We want to make sure everything's in its smallest base. And then things kind of magically work themselves out. So on the top, we're going to have k to the power of 6 because 10 times 3/5 is 6. And then on the bottom, this is 3 cubed, and then we simplify. We never leave anything we can simplify unsimplified. This becomes k to the 6th over 27. Number 4, we have 125 to the 2/7 to the negative 7/3. So I'm going to work my way inside out. The first thing I'm going to do is change 125 into its smallest base. This is 5 cubed, and then that is to the power of 2/7, and then this is all to the power of negative 7/3. When I have a power being raised to a power, we're just going to multiply all those powers. So this becomes 3 times 2 over 7, 2 over 7, times negative 7 over 3. All right, so we get negative 2 So this becomes 5 to the negative 2. I can get rid of the negative exponent by writing it all under 1. And then I'm going to simplify. 5 squared is 25. So this becomes 1 over 25. Number 5 is a little bit different. So we've got a couple of terms being raised to a power and then others being multiplied in. So I'm going to handle the first set, m to the power of 3, p to the power of negative 6 to the power of negative 1/3. Now, same thing goes when terms are being multiplied together, we can distribute that power as well. So anytime we've got terms being divided or multiplied, we can distribute the power, but that is it. Addition or subtraction, it doesn't work. So I'm going to distribute this. This is going to become m to the negative 1 times p to the negative 2, positive 2. And then this is all being multiplied still by m squared times p to the negative 2 power. All right, so then next we've got similar bases or same bases. So rules of exponents tell us this: if the bases are the same and they're being multiplied, we add the exponents. All right, so this is m to the power of negative 1 plus 2, and then times p to the power of 2 plus negative 2. This is going to give us m to the power of 1 times p to the power of 0. Anything raised to the power of 0 is always just 1. And so we're left with just m. We never write m to the power of 1. We never say anything to the power of 1. You just leave it as the base itself. Number 6, 64 r to the negative 9th, all being raised to the negative 2/3 power here. I am going to deal with that 64 first. So 64 is 2 to the 6th. This is r to the negative 9th. And then I can distribute that negative 2/3 power to both of the terms because they're being multiplied. So I'm going to say this is 2 to the negative 4th times r to the positive 6th. And then I've got to deal with that 2 to the negative 4th. We can't have negative powers here. So this is r to the 6th over 2 to the positive 4th now. And then all that's left to do is simplify that 2 to the 4th. So this is r to the 6th over 16. Number 7 is where things get a little bit more complicated. So in the case of number 7, we are not allowed to distribute this 2 to both things, right? That's like saying x plus 1 squared. We're not allowed to distribute that 2 and make it x squared plus 1. Okay, so it doesn't work like that when the terms are being subtracted or added together. So the way that we've got to approach this problem is kind of from the inside out. We've got to simplify things first. So 49 to the power of 1/2. 49, I can rewrite as 7 squared. And then 36 is also perfect square. It's 6 squared. And then what happens with those powers on the inside, we multiply. So 2 times 1/2 is just 1. And again, 2 times 1/2 is just 1. So we end up with 7 minus 6 squared. And we can do 7 minus 6. It's just 1 squared. Our final answer here is just 1. In the case of number 8, we are allowed to distribute this power because the bases are being multiplied. So 49 and 36 are being multiplied. That 2 can go into both of those terms and apply directly. So in this case, this becomes 49 times 36 because 1/2 times 2 is 1. And then I'm just going to simplify that. That's 1,764. 9, 10, and 11 are the trickiest ones on the page. We want to make sure you guys are really good with these ones. So I've got a term on the outside and then 3 terms on the inside, and I'm going to distribute this term. We can do that. We're not distributing a power, we're distributing the term. So it's like having something like this, right? We're distributing that term on the outside. It's not the power that we're distributing. So what that looks like is that becomes z to the 4/5 times z to the 2/5 minus z to the 4/5 times z to the negative 4/5 minus z to the 4/5 times z to the 6/5. And then when we've got bases that are the same, that are being multiplied, so in this case we've got z's that are being multiplied together, the rule is we just add the exponents. So this is z to the 4/5 plus 2/5 minus z to the 4/5 minus 4/5 minus z to the 4/5 plus 6/5. All right, simplify. Final answer here. This is z to the 6/5 minus z to the 0 minus z to the 10/5. Okay, so this is z to the 6/5. That doesn't simplify anymore. Z to the 0 is 1. And then z to the 10/5 is just z squared. Final answer looks like this. Okay, don't drop the 1. Z to the 0 doesn't cancel. It goes to 1. Okay, with number 10, here's the way I would do this. I'm going to separate out the terms. So I'm going to put both of the terms in the numerator over a separate denominator. That is going to become 7n to the 1/5 over 7n to the negative 3/5. And then separate of that, minus 28n to the negative 3/5 over 7n to the negative 3/5. So I'm just going to repeat that denominator. If I were to combine those with that common denominator, we'd get back the original problem. But having the terms kind of separated out is going to help us approach the problem a little bit better. Okay, so then what happens? We've got two different things. We've got a coefficient and then we've got an actual variable. Now in the first term, the 7s cancel. In the second term, 28 divided by 7 is 4. So the coefficient of that second term is going to be 4. Now, rules of exponents tell us this. When the bases are being divided, so in this case, we've got n's over n's. When the bases are being divided and they are the same, we are going to subtract the exponents. So it's very similar to the multiplication. When bases are being multiplied together, we add the exponents. When bases are being divided, we subtract. So the first term is going to become n to the 1/5 minus negative 3/5. We always do top minus bottom. And then this is minus 4n to the negative 3/5 minus negative 3/5. So just be really, really careful about the signs here. So this is going to be n to the power of 4/5. And then minus 4n to the power of 0. Now we're never going to leave n to the power of 0. That goes to 1. So this is just 4 times 1. Our final answer is n to the 4/5 minus 4. Last problem in the example section is number 11. So we've got this weird looking thing, and there's actually two ways we can approach this. So I'm going to do it both ways, and then kind of you can pick which one you like better. So the first way I'm going to do is, because this whole term 30a to the 3/4 is being multiplied into 2a to the 1/2 minus 5a to the negative 3/4, what I can do first is just pull this piece out, what I've circled here. I could rewrite it like this: 30a to the 3/4 over 10a to the negative 3/4 times 2a to the 1/2 minus 5a to the negative 3/4. And I'm going to kind of approach it like that. I'm going to figure out what that 30a to the 3/4 divided by 10a to the negative 3/4 is. And then whatever that simplifies to be, I will distribute into what's inside the parentheses there. So 30 over 10, that simplifies to just 3 on the top. And then what happens is we get the same bases being divided. We're going to subtract the exponents. So this is 3a to the 3/4 minus negative 3/4. And then we'll distribute that into 2a to the 1/2 minus 5a to the negative 3/4. So this simplifies to be 3a to the 6/4. And then times 2a to the 1/2 minus 5a to the negative 3/4. All right, so let's actually distribute that. I'm not going to worry about simplifying till the very end, but it doesn't matter where you simplify at what step. Okay, so everything gets multiplied by 3a to the 6/4. And so this is going to become, I'm going to write this over here on the far left-hand side. 3 times 2 is 6. And then when I've got the bases being multiplied that are the same, I add the exponent. So this is 6/4 plus 1/2. And then minus 3 times 5 is 15, and then a to the 6/4 plus negative 3/4. All right, now we've got to simplify everything here. This is going to become 6a to the 6/4 plus, I can make this 2/4, and then 15a 6/4 plus negative 3/4 is just 3/4. So final answer, 6a to the 8/4 minus 15a to the 3/4. There's one more step. We've got to simplify that to a squared. All right, so option 1, final answer there. Simplified the term on the outside in the numerator over the denominator and then distributed that into the set of parentheses. We could have approached number 11 a different way. So we could have approached number 11 a little bit more similarly to how we approached number 10. So the first thing is I'm going to distribute everything in the numerator, and then I will deal with the denominator last. So when I distribute everything, that 30a to the 3/4 into everything inside the parentheses, we're going to get 60a to the 3/4 plus 1/2 minus 150a to the 3/4 plus negative 3/4. And this is all still over that 10a to the negative 3/4. All right, now when I simplify, this is 60a to the 5/4 minus 150a to the 0. So that's just going to be 150. And then all still over that denominator, 10a to the negative 3/4. But this is where it's going to look more similar to number 10. I'm going to put each of those terms in the numerator separately under the denominator. And now I'm going to simplify with that division. So 60 divided by 10, that's just 6. And then we're left with a to the 5/4 minus negative 3/4. And then minus 150 divided by 10 is 15. And then this becomes a to the 0. Remember, we had a 0 there. So a to the 0 minus negative 3/4. All right, when I simplify, we're going to get 6a squared. 5/4 plus 3/4 is 8/4, which is just 2. And then minus 15a to the 3/4, which is the same answer we got the first way. It doesn't matter which way you guys choose. Stick with the one that makes more sense to you, and then go about evaluating those problems just like one of those methods.